Hi, good day. I'm Besmak Buafo, a student of GCTU, a DIT student, and I'm here to present why the data path cycle have a huge impact on the CPU performance. Yeah, and then another question: how does the CPU fetch, decode, and execute instructions? So let's take the first one. So we say that the data path cycle or the pipeline plays a crucial role in determining the CPU's performance. So let's look at some four key ways in which the data path cycle impacts the CPU's performance. So the first one is pipeline stalls. It says when the pipeline stalls due to data dependence or branch mispredictions, it can lead to significant reduction of the performance of the CPU. So normally when the pipeline stalls due to the data's dependence on the branch, it leads to the significant reduction of the performance of the CPU. And then we are looking at the next one, the poor consumption and heat generation. Poor consumption and heat generation. So it says that an inefficient pipeline can lead to increased power consumption and heat generation, which can throttle the CPU's performance and reduce its lifespan. So, like high power consumption and then the generation of heat during, let's say, processing of some information or data, it says it can lead to increase. It can lead to the throttle of the CPU's performance, reducing the performance of the CPU, and then reducing its lifespan. It's going to reduce the lifespan of the CPU. And then we are looking at our third point, instruction level parallelism. The pipeline's design influences the CPU's ability to execute multiple instructions in parallel. The pipeline's design influences the CPU's ability to execute instructions parallel. A computerized pipeline enables more instruction level parallelism, boosting the performance. Yeah. So normally, um, sorry. So the CPU's ability to execute multiple instructions in parallel. When you look at an optimized pipeline, when you have an optimized pipeline, it enables more instruction level parallelism. Yeah. So when that happens, when you have an optimized pipeline which enables more instruction level parallelism, it boosts the performance of the CPU. Uh-huh. So we are moving on to the next question, and the next question says that how does the CPU fetch, decode, and execute instruction? How does the CPU fetch, decode, and execute instruction? So here we are looking at how the CPU fetches and then decode and execute instructions. So looking at the first one, how it fetches, it says the fetch instruction. The CPU retrieves instructions from the memory. It retrieves instructions from the memory. And then the second one, which is decode, says that the instruction is decoded. So the instruction that the CPU retrieves from the memory is decoded and then requires operands and retrieved. Yeah. So the information that is fetched from the CPU or retrieved from the CPU, sorry, retrieved from the memory, the it's been decoded. That instruction is decoded and then requires operand and retrieved. Then The next step is execute. Execute. It says that the CPU performs required operations such as arithmetic or logical operations. So here, the retrieved information or instruction that has been decoded is being executed. Yeah, the information is being executed. So the CPU performs the required operations, such as, so maybe it could be an arithmetic, like some sort of calculation, sort of something. Yeah, or it could be a logical operation. And then the next step is memory access. Memory access. It says that the CPU accesses the memory to retrieve or to store data. The CPU accesses the memory again. So after the information, the instruction, um, after the execution process, we get to the memory access where the CPU accesses the memory. It accesses the memory to retrieve and then to store the data. Yeah, and then we are looking at the last step, write back. Write back. So in this step, the results of the instructions execution are written back to the memory or the registers. The results of the instructions after the execution process are being written back to the memory or the registers. So this is here I draw the curtains to my presentation, and thank you very much. Have a wonderful day.